So welcome to another video. We're going to show two simple things today. The first one is to how to highlight your waveforms to give them a little bit more visibility. And so the second part is printing. So we'll talk about that in a second. So the first part is about the waveform. Normally, if you come down in the do file that we talked about in the second video, you'll actually see that there's a line here. It says add the waveform. So let's see if we can take a look at this. So add wave. Now usually you do it in hexadecimal. You don't have to do it. You could remove that if you want everything in binary. But I typically do everything in hexadecimal. -R, and then I usually have the top level hierarchy, which is TB, which we found out from our previous compilation, and star. Now what that typically does is it puts all the files in the simulation. So let's run this with just that portion. So let's take a look. So I just say add wave -hex -R TB star, and let's save this and run the do file. So it looks like everything went correctly. It's simulated. Now, one of the bad things about this is that it actually shows you lots and lots of files. You can see there are a tremendous number of files. And the reason why it does this is because I put a /TB star. And so what happens a lot of times is it recursively goes down and it lists every signal that's in your simulation, and some of those signals are actually repeated. So you can see here some of them are repeated because of the way the waveform is utilized. That's not a very good way of doing it. And so what I tell a lot of people is once you have everything you think it's simulating, and you really want to narrow down your simulation to make sure it works, come back to your do file and try to segment your waveforms so that they are more informative for your user, in other words, for you. For example, take a look here. I put this little file here. It says add wave -no update divider, and it just has a text that says, hey, I want to leave a little line that says data path, and then this line adds all the data path parts, and then I have a new divider called control. Here's all my control parts, and then here's a part for its output, actually, for a speaker, and it shows you all these are for the speakers. So what I've done here is I've highlighted only the signals that I want to see, and it just makes it a lot easier to debug. So let's take a look at this, save it, and let's see how this looks when I simulate it. So remember before I had all my signals on the left and there were a lot of them were repeated, but now on the waveform you can see I have a little signal divider called data path. They're all listed here in between this next divider line and here. I can take out the hierarchy and do the blue dot, or zoom into all. And you can see it's very easy to see all my signals, go through and figure out, hey, these are my data path signals. These are my control signals. And then these are the signals for the speaker. And they're very easy to debug. So I highly recommend to do that. So the second part of this video is about printing, and for me it's a very difficult thing for printing because sometimes you would like to have something printed out, and unfortunately a lot of people give up on printing, and what they typically do is they take a screen print of this. Now that's a really bad idea because it takes up a lot of ink in your printer. A lot of times you can't look at it really well, or if you want to include it to somebody else it's hard to do. So I tell people this is the next part of the tutorial, is how to print to a Postscript file. So let's take a look at this. So I do File, and then go over here to Print Postscript. Now what this does is it prints to a file that uses something called Postscript. The Postscript was a language invented by, I'm not sure if it was by Hewlett-Packard or by associate of Hewlett-Packard, but it's a text-based format, and it's very easy to understand for printers. And it makes it very easy for you to take a file that you can save for whatever you're going to do. What's great about this is you could do the different time ranges if you want to do the full range, or if you want to do a custom range, like say you want to go from, let's say 10 nanoseconds to 25 nanoseconds. You can do that. But we're just going to do the full range here. You can click Setup, and it'll allow you to change the format if you want landscape or portrait. You can do different types of things if you want to grid on, inches, margins, anything, paper size, whatever you want. And make sure you click here, file name. If you include it in your Word document or another document, typically you export to an EPS file. That's a lot easier. So make sure you click that if you're going to a Word file. If you're not, if you're just going to a Postscript file and you want to print, just do it to this first, to the wave.ps or whatever you want to call it. We'll just call it james.ps there. And then just hit OK. So it looks like it printed. Everything is great. I can exit out of my waveform. And hopefully in this directory is something called james.ps. See it right here. Now if I look at james.ps, it'll be just a lot of text. And this is the language that Hewlett-Packard invented, I think they invented, for Postscript files. Now, most people are not familiar with Postscript. They're more familiar with its compressed form, which is called Acrobat PDF or PDF. And so what you can do is, I recommend is, try to convert that to a PDF. Now, if you're in Unix, you can type ps to pdf .james.ps and it'll convert it for you. Or if you're on a Windows machine, just go to a website. I think there's a ps2pdf.com. It's a great converter for you, and it'll convert. You just choose the file, and it'll convert it for you. So once you do that, it creates the PDF, and you can open it up with your favorite PDF viewer and even print it if you want. So it's a very cool thing to do. Saves ink. It shows you what date it ran and all this other information. So I hope you enjoyed that. Have a great day.